Hello students, today we are going to do different theories regarding the structure of atom. Before starting this topic, let us subscribe the channel Chemitutorial and press the bell icon. So regarding the structure of the atom, there are different theories given by the different scientists. First ever theory was given by J.J. Thomson, then Rutherford came, he gave his own theory, and at the end then Bohr gave the theory. Afterwards classical quantum mechanic model came. So different theories are there. Here we are going to discuss three theories: Thomson's theory, then Rutherford's, and afterwards Bohr's theory. Now let us discuss what was the theory of Thomson. So Thomson gave a model of atom. So according to Thomson, J.J. Thomson, he considered the atom to be a solid sphere in which electrons are embedded here and there haphazardly, not at any regular place, but here and there the electrons, that is the negatively charged particles, they are spread here and there haphazardly. So according to Thomson, the atom is just like a solid sphere. This is atom, model of atom given by Thomson, and electrons according to him are negatively charged particles which lie here and there in irregular manner, and this positive charge sphere has positive charge distributed on it here and there. Total positive charge on the sphere is equal to the total negative charge on the electrons. So on the whole, the atom is electrically neutral. This is a simple model given by, just like a watermelon model. Why do we call it a watermelon model? When you cut open the watermelon, black colored seeds are seen in the red edible part of the watermelon, and the seeds, they don't have any fixed location, no fixed position is there. So when you cut open the watermelon, they are found here and there, you can't guess where the seed is. So it is also called Christmas pudding model. Why Christmas pudding model? Because in the pudding raisins are there, kishmish, etc. lying here and there. You can't guess where you are going to find almonds, raisins, etc. So watermelon or Christmas pudding model, this is called. And it tells us that atom is neutral. But according to Thomson, electrons, they are stationary. They are not moving here and there. Inside the solid atom, they are fixed at a fixed position. They are not moving. This was just a simple model given by Thomson, just giving a concept of positive and negative charges equal in magnitude, so that it is electrically neutral. So if we want to discuss Thomson's model in the form of postulates, we can take two main postulates. First point, you can say that atom is a positively charged sphere and positively charged sphere with electrons embedded in it. Second, you can say that the magnitude of negative charge on the electrons and the positive charge on the sphere, the magnitude is equal. Magnitude of positive charge on sphere and negative charge on electrons is equal, and as a result atom as a whole is electrically neutral. So these are the main postulates of Thomson's model of atom. So there were few drawbacks of Thomson's model also. It is not so correct, not accepted by the scientists who experimented later on different experiments. This model was rejected, Thomson's model was rejected. And what was a drawback? What led to its failure? Actually, Rutherford was a scientist who performed an experiment which led to the failure of the Thomson's model. Now let us discuss first Rutherford's experiment, which is also called alpha particle scattering experiment. According to this experiment, Rutherford took a very thin gold foil. Say this is gold foil. He took a gold foil and he passed a stream of alpha particles through the gold foil. So this is a stream of alpha particles coming here, a beam is coming made up of alpha particles. What he observed that most of the alpha particles, they passed straight through the gold foil. They passed through the foil, and you know that this gold foil is further made up of atoms of golds, and it was amazing that alpha particles has passed through it. That means they passed through the atoms of the gold. That means, so this experiment of Rutherford gave an objection to Rutherford's model, because according to this gave objection to the Thomson's model. Why? Because according to Thomson, the model of the atom is solid, but as was observed by Rutherford in this experiment, that the alpha particles, they were able to pass through the atoms. So that means atoms must not be solid. So that is why, because Thomson could not explain the reason for this observation of Rutherford, he was not able to explain the alpha particle scattering experiment performed by the Rutherford. So his model was rejected. This was the drawback of Thomson's model. Now let us discuss Rutherford's experiment in detail. How did he perform? What was the setup? And what did he observe? How did he perform it? So he selected a gold foil. It was as thin as 1000 atom thick. So his experiment, if we discuss in steps, first he selected a gold foil, 1000 atom thick, 1000 atom thick gold foil. So this much thickness of the gold foil is not so thick, it is very, very thin actually. 1000 layer is a very, very thin layer. So he took a very thin foil of the gold having at least 1000 atom thickness, and then he striked a stream of fast moving alpha particles. Fast moving alpha particles have lot of energy and they are also very heavy, because you know that alpha particle is actually helium atom, or you can say ion having 2+ charge. This is alpha particle, helium 2+ ion, high energy and high mass took the gold foil, then passed a beam of high energy, high mass and high energy alpha particles through it, through gold foil. And he expected that alpha particles would be deflected. They will strike, they are very heavy, they will strike the gold foil and will come back in different directions. He expected this, but this was not so. So this was his setup and expected deflections at small angles. Now what is the meaning of deflection? Like this alpha particle is going and striking here, will come back at small angle, not at large angles. He expected that if they will strike here, come back at very small angles, but it didn't happen. So what did he observe? So this was his experimental setup. How did he perform? What he selected? He selected a foil and alpha particles beam, and this was his expectation. Now let us discuss the observations which led to postulate the atomic theory. What did he observe? He mainly observed three observations. First, he observed that most of the alpha particles, fast moving alpha particles, they passed straight through gold foils. Most of alpha particles, since they were very fast moving, passed straight through the gold foil. What did he observe then? Some of the alpha particles were deflected at small angles. And rarely, very few, they bounced back, say 1 out of 12,000, 1 out of 12,000 bounced back. At an angle of 180 degrees. Surprising. Most were passing straight, but few were bouncing back also. Amazing. So three type of observations he made, and from these three type of observations he was able to conclude something which led him to give the theory, atomic theory. So what did he postulated? What did he concluded? Now let us discuss his conclusions from these three. These are the observations. So what were the conclusions drawn from these 3 points only? First point we discussed was that most of the particles, they passed straight. That means most of the space in an atom is empty, vacant. That is the reason for passing them straight. Second, few were deflected and at an angles. This means something positive is present inside the atom. Something positive occupying small space is present in an atom. And third observation was that few particles, they bounced back at an angle of 180 degree. That means something hard is there which occupies very small part, very small space. That means the whole mass of the atom, is concentrated in very small portion or volume or space. So these were the conclusions drawn from his observations, and from these conclusions he gave 3 postulates or 3 points of his theory. So most of the space is empty. It gives us an idea. It gave idea to the Rutherford that there is a positive nucleus which is present in the center of the atom, and the mass of the atom also is residing inside the nucleus only. So now let us tabulate the main postulates. Postulates means we are now giving the Rutherford's atomic theory. So first point, that positively charged center, he gave the name nucleus. Positively charged nucleus is present in center of atom, where whole mass of atom is concentrated. Second, he said that electrons are not stationary, as was postulated by Thomson. He said that electrons, they were revolving around the nucleus. Around positively charged nucleus. They are revolving, electrons are in motion, but according to Thomson, he said that electrons are stationary, but Thomson said no, they are revolving around the nucleus in circular well defined orbits. Well defined means we can locate its path, we can guess its path clearly, on which path it is moving. Then third postulate was that size of atom is size of nucleus is very small as compared to size of atom. These were the 3 main postulates or atomic theory given by Rutherford, but later on limitations were found in this theory also called as drawbacks. Now according to Rutherford, he said that electrons are moving in well defined orbits. So we also know that electron is a charged particle of very small size. Whenever a charged particle moves in circular orbit and it's in motion, it gets accelerated. You know that circular motion is accelerated motion. Circular motion is always an accelerated motion. So whenever a charged particle is getting accelerated, because we have assumed, according to Rutherford, it was assumed that electrons are evolving in the well defined orbits. Here the electrons are evolving, and electron is charged particle. When it is revolving in circular orbits, it is getting accelerated, and when charged particles gets accelerated, they radiate energy. Radiate energy means they will lose energy, and if they will lose energy, they will be attracted towards the nucleus, and if they are getting attracted by the nucleus, then it is obvious that they are being attracted by the nucleus. And then what will happen when they are getting accelerated and attracted by the nucleus? They will slowly follow a spiral path and fall into the nucleus. Hence atom will collapse, but it never happens. Collapsing of atom means atom is unstable, but atoms are quite stable. They cannot be destroyed, they don't get collapsed. So this was the main drawback of Rutherford's theory, which led to the failure of Rutherford model also. After that came Bohrs model. After the failure of the Rutherford, Bohr gave a theory, Niels Bohr. A great scientist he was. When Bohr gave his theory, he said that electrons, they are revolving around the nucleus in certain special orbits, and revolve around nucleus certain special, you can say, allowed orbits. And while revolving in these orbitals, electrons do not radiate energy, they have fixed energy. So what is the difference between Rutherford's model and Bohr's model? According to Rutherford, it was assumed that around the nucleus the electrons are revolving in circular orbits, and according to Bohr, that these orbits, they are certain special allowed orbits, means the radius is fixed for an atom. It's, for example, for an atom, this much is the radius. At this radius, the electron is allowed to revolve here. It cannot revolve at this radius, this much different distance or this much distance. So allowed state means that orbit where its energy is also fixed, and in each orbit the energy of the electron is also fixed. Here different energy, and in the second orbit more energy but fixed amount, there is difference between them, and it is not radiating energy when it is moving inside the same orbit. When it changes the orbit, only then its energy changes. It happens, so we will study in higher classes that electrons can change their orbit also by jumping to the higher levels also. So these are the main postulates given by Bohr. Bohr called these orbits as energy shells, energy levels also. These orbits he called as energy levels also, or shells, and called them as first for he gave the numbers n is equal to 1 for the first orbit. He said that value of n, he gave values of small n as n is equal to 1 for the first, this for first one, n is equal to 1, it is also called k shell. Then next he called L, next m, and fourth n, so on. Small n is equal to 1 here, small n here is equal to 2, here it is n is equal to 3, and then n is equal to 4, so on. So this was the model given by the Bohr. Now we will draw Bohr's model for few atoms, few elements. Now let us start with the hydrogen atom. You know that hydrogen is having 1 proton, 1 electron. So it is having single orbit, but before drawing the Bohr's models, Bohr and Bury were two scientists which gave few rules. Bohr along with Bury gave few rules how to distribute electrons in various shells. According to these theories, he said that maximum number of electrons, maximum number of 2n square electrons can be accommodated in an orbit. Secondly, he said that outermost orbit can have maximum 8 electrons. And third rule he gave that electrons are filled in increasing order of energies. Of shells, energy shells. So according to 2n square rule, as you know, according to Bohr, for first shell n is equal to 1, for second n is equal to 2, for third n is equal to 3. So maximum 2n square rule for first shell, n value put n is equal to 1 square. First shell can have 2 electrons. Then for n is equal to 2, n square, 2 square, 8 electrons. Then for third, 2 into 3 square, 18 electrons. So in this order, maximum number of electrons that could be accommodated is given by 2n square rule. And if an atom is having 4 shells, maximum 4 shells are there. So one first shell can have 2 electrons, second can have 8 electrons, then third can have 18 electrons, and if the fourth shell is the last shell, it can have maximum 8 electrons. That means 2, 8, 18, 8 again. And if an atom is having 2 shells, and we write the electrons by adding commas. If an atom is having 2 electrons in the first shell, 8 in the second, 18 in the third, we will write like this, adding commas. Last is having 8 like this. If one atom is having 2 in the first shell, 8 in the second, then like this. If atom is having 2, 8 and third shell is the last shell, then third can have maximum of 8 electrons. So this we will show by drawing different atoms of different elements. So that topic we will discuss in the next stream. So in this stream we have discussed different theories of the atoms. Revise these topics, and next time we will meet when we will draw different Bohrs models for different elements we will draw. Till then, bye students.